Gentlemen, today I'm going to be looking at making 3D printed gears spin freely around the shaft and securing them so that they don't fall off. Now, if you were doing this the normal way, what you want to do is put a little coupling or maybe another threaded fastening at the end to secure the gear. But if you're doing this entirely 3D printed, your life is a little bit harder. Now, obviously, this only works in low speed and reasonably low torque scenarios, but with these kinds of shaft, you don't want to apply too many forces because they're extremely brittle. I found that they snap off easily when you don't look at them. So you're better off actually using a much thicker shaft if you can while 3D printing gears. So, in order to secure the gear right in the shaft like that, my first idea was to use these flexible little fasteners, because unfortunately the 3D printed shaft has a tendency to shrink and warp. So you want something that's relatively flexible and gives you a bit of leeway. Now, I'm going to be using this wheel for testing purposes, but this applies as well to gears and any other similar rolling apparatus. Now, as for this method of fastening, you gotta make sure that the diameter of the shaft matches the inner diameter of the fastener, because you would think that a tighter one would be tighter, but it's actually the opposite. It's just a difference of 0.25 millimeters will lead to mechanical deformation, which will actually make the tighter one looser. Here you can see that it slides down much more easily than the one that has a larger diameter. Now, there's no reason to make them this thin, so I've doubled the thickness and width of the fastener here, and it's just as flexible as its thinner counterparts. As for the wheel, to ensure smooth turning without too much friction, I've made it about 5% larger for its inner diameter compared to the shaft. For the first minutes of operation, there was a bit too much friction and it had some issues with smoothly turning, but eventually it would seem that the parts basically centered themselves automatically, and now they turn fairly smoothly. However, using them for both ends of the wheel, it wasn't such a good idea, because as you turn the part, you'd see that the little fasteners would start increasingly moving about on the shaft, and eventually the wheel would just fall out of place. So, I tried a second approach where I made the shaft itself hold the gear. But unfortunately, since I printed this vertically, the plastic at the bottom had bridging issues and drooped down. It's just as functional, but aesthetically speaking, it's not exactly ideal. You could always put some supports, but this is a fairly edge case, so most of the time you won't really run into this issue if you're designing your part correctly. Now, this is a much more intuitive fit as you just pop the wheel in there, pop the fastener, and you just gotta play around a little to make it have the space it needs to turn freely. But I was still a bit worried that this wheel wasn't actually properly secured, as eventually the fastener could still fall off. So I made a second design, which was just a little cap that would press fit on the shaft and secure the wheel in this manner. This is the one I ended up choosing for the gearbox, although it requires a bit of fiddling. Once it's in, it's pretty much guaranteed not to come out unless you pull it out. You just gotta watch out that there's enough space between the fastener and the gear or wheel, because if they touch each other, they'll create friction and the turning won't be as smooth, and you'll have to apply a bit more force to keep them turning. But with a bit of play between the two, I found that this is a very workable approach if you can't be bothered to get proper couplings for your shafts. And you can see it's smoothly turning, and this is the design I ended up choosing for my gearbox. I just made a miniature version of it for this one. And the same principle apply. The press fit coupling is keeping that gear nice and secure and snug. Alright, see you next time.